Hi everyone. Today I'm going to talk about type 3 ternary ionic compounds. You saw the beginning of this last week and we're just going to continue with it today. Ternary ionic compounds contain 3 or more atoms, whereas the binary ionic compounds that we saw the past couple of weeks only contain 2. All of these ionic compounds will contain something called polyatomic ions. Poly means many, so the poly part means many, and atomic means atom, so it's saying it's made up of many atoms. These ions are multi-atom ions, so instead of just like chlorine being a negative charge, it's going to be made up of many different atoms. Most polyatomic ions are negatively charged. They're anions, and they behave like nonmetals, so they want to gain electrons. There is one cation amongst them. It's called ammonium, and the formula for ammonium is NH4, and it has a +1 charge. When we write formulas and we need more than one of these polyatomic ions, we have to use parentheses to group them together. So you'll be writing some parentheses out if needed. And when we're naming these ionic compounds, they just keep their names. So we name them pretty based on what their names are. So here is a chart of the polyatomic ions. If you take a look at it, it's got the negative charges, and you see that ammonium is the only one that is a positive charge. That's right here. Okay, and so these are the formulas for each one of these. So you can see, let's take a look over here. So we've got borate. Borate is made up of BO3. So it's made up of boron and oxygen. So when we write this, we write BO3 as a group. You treat it the exact same way as you would treat the letter I or the letter F if you were looking at iodide or fluoride. So we just group this whole thing together. Okay, so if you're asked to name these compounds, there's a few references that we need. We have the polyatomic ion chart, which is up here. And then we have our periodic table, which is here, and then your transition ions here. These are all references for you to use. So you just, keep them handy so that they're easily accessible. The first one we're going to look at is is Al2SO43, okay? Now, one of the things you should look for right away is the parentheses. So since you see parentheses here, we're going to treat this SO4 as one ion. And because it's a group, we have to name it from the polyatomic ion chart, okay? But let's start with the Al, which is our cation, or which is our metal. Hopefully by now that you know that Al is aluminum, and aluminum is found as number 13 here on the periodic table. It is not a transition metal, so all we do is we name it as aluminum. Real simple, right? Nothing, we don't need any Roman numerals or anything like that. Then, to name the SO4, we have to look on the polyatomic ion chart. And on the polyatomic ion chart, you just kind of scan down, see if you can find SO4. So we look here, no SO4 there. Okay, oh, there it is, SO4. SO4 is called sulfate. So what we're going to do is we're just going to call this sulfate. So what we have here is the name aluminum sulfate. No Roman numerals because aluminum's not a transition metal, so don't forget the rules that you've already learned. And sulfate, we just named it from the chart. Our second example is FeOH3. So again, we have these parentheses here, and we have Fe. So when we look up Fe, hopefully by now you realize that Fe is iron. And that right there should trigger something in your head because iron is a transition metal. It is right here on your periodic table. Okay, so we're going to need a Roman numeral. So we've got a little bit more work to do here. But first, we're going to look up OH on the polyatomic ion chart over here. So I'm going to just go down, see if I can find OH. Oh, there it is. OH is hydroxide. It has a -1 charge. So we're going to name it hydroxide, okay? So now we just have to figure out which iron we're using, okay? In order to do this, you do it the same way you did it before. You use the nonmetals and the charge to figure out what the charge of the metal is. So if we look here, okay, so I have 1 Fe in this formula, and this little 3 right here is telling me that I have 3 OHs. So I have OH, OH, and you just leave it as a group, okay? You don't separate them. Each one of these OHs has a -1 charge. So we have 3 -1 charges for a total of -3. If we look back at iron, we only have 1 iron, so our iron charge, because we need a +3 total charge, right, to cancel out, this 1 iron has to have all 3 of those positives. So it's going to be iron plus 3. So the Roman numeral we would need would be iron 3 hydroxide. Okay, it's exactly the same as we've done before. Okay, so I'd like you guys to try this one, Mg2SiO4. You know right away that there are 3 different elements. You can see we have Mg, we have Si, and then we have O. Those are 3 different elements, so this is a ternary compound, which means you're going to need this polyatomic ions chart, okay? So when we look at Mg, the first thing we're going to do is name it, right? Mg, when you look it up, is right here. It's magnesium. It is not a transition metal, so to name that, we just put magnesium. The second part is now we have to look at this polyatomic ion here, okay? This little 4 means nothing for naming. It is just a part of the polyatomic ion. So now we have to go look at the polyatomic ion chart and we have to look up SiO4. So I'm going to go through here. No ISO4 there. Oh, there's SiO3, but that's not the same. It has to match perfectly. So there's no SiO4 there. No SiO4 there. Oh, there it is. Okay, so here is SiO4. The name of it is silicate. So we're just going to write out silicate. And that's it. Okay, let's try one more. We have Cr2 and then parentheses C2O4 close parentheses 3. Okay, so the parentheses are going to be a big hint to you that, again, you're going to need to use this polyatomic ion chart. But let's start with Cr. Okay, so Cr2, if we look up Cr on the periodic table, we see it's right here. It's a transition metal. That should send something out in your brain that says, oh, it's a transition metal. I have to look at my my chart, okay, and I'm going to need a Roman numeral. So Cr is chromium, so we're just going to name this as chromium. And we're going to leave it for a moment to, we have to figure out what Roman numeral we need, okay? And then we have to look up C2O4 on our polyatomic ion chart. So I'm looking for C2O4. It is not there. C2O4. Oh, there's a CrO4, but that's not the same. Okay, there's a Cr2O7. No, oh, there it is, C2O4, and that is called oxalate. So we just name that as oxalate. Okay, now we need to figure out what this Roman numeral is going to be. So we have to look up what was the charge of this oxalate. So here's oxalate. Oxalate is in the -2 box. So we have, and I'm just going to draw this all out just so you can see it. If we look here, okay, we have C2O4. That's a group. Remember, treat that the exact same as you would treat the letter I or the letter F. Okay, this 3 on the outside of the parentheses is telling us that we have 3 of those. I'm sorry, 3 of those. And each one of them has a -2 charge. Okay, so that means our total negative charge is -6. So now we got to look back at the chromium. So this 2 is telling us that we have 2 chromiums. So I'm going to write chromium 2. And we know that the total positive has to be a +6. So because I have 2, I'm going to take 6 divided by 2 to figure out what the charge of each one of these is going to be, and you'll figure out it's going to be a +3. Now that we know that this is a +3 ion of chromium, the Roman numeral we're going to put is going to be a 3. So the name of this compound would be chromium 3 oxalate. So I think I went through all the different types you'll see. We saw some with non-transition metals, we saw some without parentheses, we saw some with transition metals, and with parentheses as well. So make sure you upload a picture of your notes, and if you have any questions, feel free to ask. Have a great day. Okay, so to write the formula, it's basically the same way you did it for type 1 and type 2, you've just got a different ending over here, okay? So the ITE ending is going to tell you that you're going to need something from the polyatomic chart. So the phosphite is right here, and this is PO3, and it has a -3 charge. Beryllium is a fixed charge, and it is right here, it's in column 2, so that means it's got a +2 charge. Okay, we have to make these charges equal right now. So what I'm going to need is another one of these and a couple more of these. So now I have 2, 4, I have a +6 and a -6. So to write this formula, I'm going to have E3, because I have 1, 2, 3 of these. And I'm going to have PO3, and since I have 2 of them, I'm going to put them in parentheses and put the 2 on the outside, okay? So this would be the formula for this. Okay, so this one is a little bit easier. You see a Roman numeral, so you know right away that's the charge of the metal. So we have iron +2, okay? And then we have iodate. So when I locate iodate on my polyatomic chart, how did I know to look? Because it doesn't have an IDE ending. So I can see that it is O3, and it's in the -1 column, so I put it, or -1 column, sorry. Okay, so are these equal? No, I'm going to need another iodate ion. Okay, now I have 2 and 2, so I end up with 1 Fe, okay, and then I have 2 IO3s, so I put those in parentheses, and then I put a 2, because I have 1, 2 of them on the outside here. Okay, all good. Do this practice in your notebook.